everybody, welcome to our week 12 quiz tutorial. This week you guys did a lot of operations with rational expressions, so tried to break that down into pieces for you and ask a little bit about each thing. For number 1, I'm just asking for the least common denominator. Okay, so we have 3 different rational expressions and we want to find that least common denominator, presumably so we can add or subtract them. Okay? So to find a least common denominator, I don't care about the numerators at all. I just am focusing on the denominators, okay? And the first thing you're going to do, like everything else in this chapter, is factor. So x squared minus 9 factors as x plus 3, x minus 3. For my second one, x squared plus 5x plus 6, that one's going to factor as x plus 3, x plus 2. And the last one, x squared plus 6x plus 9, that factors as x plus 3 squared. If you want to write it out, that's x plus 3 times x plus 3. So then we're ready to actually look at our least common denominator. So our least common denominator has each factor from every single denominator the most times it occurs in a single denominator, if that makes sense. So what I do personally is I just go one denominator at a time and add them to my list. So my first denominator, I need an x plus 3 and an x minus 3. So I'm going to put that in my list. X plus 3 and x minus 3. Then I look at the next one. It needs an x plus 3. We've already got that in our list, so we don't need to repeat it. But it also needs an x plus 2. I don't have that listed down here, so I need to add that in. So I'm going to add an x plus 2 to my list. The last denominator needs 2 of these x plus 3s, and my list right now only has 1 x plus 3, so it's not quite happy yet. It needs 2 of them. Okay, so you just need to add an extra x plus 3. So you can either add an extra parenthesis, or if you want to put this as squared, that works as well. Okay, and once you multiply them together, which we kind of listed them out as multiplied together, that's your least common denominator, and that's it. Okay? Let's move into some addition and subtraction, okay? So, in order to add or subtract, they have to have the same denominator. So that's one thing that you're going to have to check first. And number 2, I was nice and gave you one where they already had the same denominator, so you didn't have to worry about it, okay? So they already have the same denominator. It's x plus 5. We're ready to go, okay? So to add or subtract, the denominators stay the same, and then you just add or subtract the numerators. Are you ready? Let's do it. Okay? So subtracting our numerators, this would be 4x plus 7, and then I'm going to subtract both of these terms. So that means I'm going to subtract 2x, and I'm going to subtract 9. It's kind of like distributing the subtraction. The denominator stays the same. It's just like fractions where you're changing the quantity, you're adding or subtracting the quantity, but the size of your piece doesn't change. Okay? So our denominators stay the same just like when you do operations with fractions. Then it's just simplifying. So combining like terms, 4x minus 2x would be 2x. 7 minus 9 would be negative 2. And my denominator is still x plus 5. And at this point, you're pretty much done. The only thing you kind of check for is, can I simplify it at all? And really to simplify, you're just factoring a little bit and seeing if anything factors out. So I do have a GCF in the numerator, so I can factor out a 2 if I want to. And that would be 2 times x minus 1 over x plus 5. And those are not the same factors, so it's not going to simplify at all. So either one of these answers is perfectly fine. Both of those are correct. So you can give me the factored version or the non-factored version. Either one is good. Alright, next one. In number 3, I asked you to add a couple of rational expressions together, and this time they do not have the same denominator. One denominator is x plus 2, and the other one is x minus 2. They're very similar, but they are not the same. Okay? So first thing is we need to find that least common denominator and get the denominators to be the same before going any further. So my factors for my first denominator is just an x plus 2. And my factor for my second denominator is an x minus 2. And so my least common denominator has both factors from both denominators, okay? So that's an x plus 2 times x minus 2. Then, what you're doing is you're making equivalent rational expressions. You want it to have this denominator. And how you do that is by multiplying it in. You multiply by the same thing over the same thing. You're technically multiplying by 1, in case you're wondering like the math behind that. But I want my denominator to be x plus 2, x minus 2 for both of these. So in the first one, my denominator is an x plus 2. So I'm missing the x minus 2, right? So what I'm going to do is multiply by x minus 2 over x minus 2. So that's going to be x minus 1 times x minus 2 over x plus 2, x minus 2. Okay? In the second one, it has an x minus 2, and so it's missing the x plus 2. So that's what I'm going to multiply in. So I'm going to have the 4 that's already there, and multiply by the x plus 2 that it's missing from my list. And you're multiplying by x plus 2 over x plus 2, that's why it works out okay, is you're multiplying by 1. At this point, if you are tempted to simplify, don't. You'll just end up right back where you started, and it doesn't help you at all. We did this on purpose, okay? We did this so that we have the same denominators. And you have to have the same denominators in order to add or subtract. So we are now ready to add them together. And from here on, it's a lot of simplifying, so we got this. Let's see. So we are ready to add them, so we can have one big numerator. And my denominator stays the same when I add or subtract. So it's going to be x plus 2, x minus 2. While we're doing this, let's go ahead and start our multiplication, because might as well. We're going to have to sometime. If you have x minus 1 times x minus 2, you'll have x times x, which is x squared. You'll have x times negative 2, which is negative 2x. We'll have a negative 1 times x. And then negative 1 times negative 2, which is positive 2. Okay? I'm going to add to that my second numerator. So I'm doing 4 times x plus 2, so that's 4 times x, 4x, plus 4 times 2, which is 8. Alright? And from here, we can combine a lot of like terms and simplify it even further. X squared is my only x squared, so it'll stay as x squared. But I've got a lot of x's. I have negative 2x, I have negative x, and a positive 4x. So negative 2x minus x would be negative 3x, and negative 3x plus 4x would be positive 1x. Then I've also got some constants. I have a plus 2, and I have a plus 8. And 2 plus 8 is positive 10. My denominator didn't change. I didn't do anything to it. It's still x plus 2, x minus 2. And I think we're done. The only thing you check is if you can simplify it further. And that's not even going to factor. Because if you think about factors of 10, you're looking at either 10 and 1, which is not going to give you a 1 in the middle. That'll give you an 11 in the middle. Or you're looking at 5 and 2, which would give you a 7 in the middle and not a 1 in the middle. So it doesn't factor at all. So we are done. Okay. Last one I have for you is simplifying the complex rational expression. And these things look terrifying, and I promise they are not as bad as they look, especially if you break them into parts. Okay? So with this, technically you need to follow order of operations. And so this big line, this thick one in the middle, that's division. And it means that the entire numerator is divided by the entire denominator. There's basically assumed parentheses in the numerator and denominator. So what I'm going to do is I'm just going to break it up in pieces and do it that way. I'm just going to take the top, do it by itself. I'm going to do the bottom all by itself. And once I get those two answers, I'll do that division last. You ready? Good. So in the top part, what I have is x over y minus y over x. Okay. So my denominators are x and y. They are not the same, which means I can't subtract yet. So I need to get a least common denominator. So my denominators are x and y. So my LCD would be xy. So that's what I would like my denominator to be. if my first denominator is y, I'm missing the x, so let's multiply it in. So we're going to multipy by x and multiply by x. X times x would be x squared. And the second rational expression, I wanted to call it a fraction because they act like fractions. My denominator is an x, but I want it to be xy. So it's missing the y, so we'll multiply that in. So you're multiplying by y in the numerator and denominator. That's why it's okay, because it's keeping it equivalent. Y times y is y squared. Now they have the same denominator, so you can actually subtract them now. They're not like terms, so it'll just be x squared minus y squared all over xy. And that's what you can do in the top. Let's look at the bottom. So the bottom part starts out as 1 over y plus 1 over x. And again, my denominators are y and x, so my least common denominator would be xy. My first one is missing an x. It has a y, so I'm going to multiply it in. So I'm going to multiply by x over x. So 1 times x would just be x. My second expression here, the 1 over x, it's missing the y from the denominator, so I'm going to multiply that in. So I'm going to multiply by y on the numerator and the denominator. 1 times y is y. Now that they have the same denominators, you can actually add them. You ready? So in the numerator, that would be x plus y. The denominator is that common denominator, xy. Alright, we've done the top part. We've done the bottom part. We're ready to put them together. Alright, putting them together, you're going to do that big division. So we're going to do the top part, which is x squared minus y squared over xy, divided by the bottom part, which is x plus y over xy. Now, if you guys remember from division, if you want to simplify it all, you've got to factor if you can. So x squared minus y squared factors really nicely. That's a difference of 2 squares. So that's x plus y times x minus y. xy doesn't factor, it just stays as it is. And I'm going to go ahead and change from division to multiplying, by multiplying by my reciprocal. The reciprocal means whatever was in the denominator, it's in the numerator now. So there was an xy down there. Now the xy is in the numerator. The x plus y was in the numerator before. It'll be in the denominator now. Okay? So that's what the reciprocal looks like. And we're ready. Then I look for what can I divide out? What's a common factor in the numerator and denominator that divides? So I notice I have an x and a y down here. So the x's will divide out, and so will the y's. X divided by x is 1. Y divided by y is also 1. I can do the same thing with the x plus y's. So x plus y divided by x plus y is also 1, so they divide out. What you're left with is just this x minus y from the numerator. And we're done. There's nothing left in the denominator, so technically this is over 1, which is just itself. And that's it. Hopefully this helps you guys. I know that this stuff is tricky. Stay with it, okay? Keep at it. Keep working hard. And I promise slow and steady does win the race on these, okay? Just take them nice and slow. Understand what you're doing at each step. You should be able to explain why you're doing what you're doing at every single step, okay? Good luck. And if you have questions, of course, send them my way, okay? Have a great week, everybody.